we have talked about exponential functions, and all that is like saying a number to the x power, where it's either growing exponentially or it's getting smaller exponentially, depending on if you have a number bigger than 1, it grows. If you have a number smaller than 1, like a fraction, it's decreasing, right? So we're going to look at the inverse of that function. The inverse is kind of like the opposite. The inverse of an exponential function is called a logarithmic function.
This is hard.
What did I say? A logarithmic function. So the parent function for exponential, so if b to the x power equals a, like a number, I'm going to call a another number, so we've got a and b and x, then the inverse of that, then log base b of a equals x. So all we're doing is kind of switching that equation around. We're taking the inverse of it. We're switching it around to write it in a different way. And this is actually going to help me solve for x. Because if I said, for instance, and we're going to look at some examples, but if I said 5 to the x equals 10, I wouldn't know how to solve for x just looking at it. Like, how would I get what x is? It's probably somewhere between 1 and 2, because I know it's bigger than 5, but it's smaller than 25. So it's somewhere between 1 and 2, but I don't know exactly what that is. So we're going to learn how to actually solve for x when it's in an exponent like that by taking the log of it, is what it's called, or finding the inverse function. So we're going to take all of these exponential forms that you see, and we're going to switch them around into log form so that eventually we can solve for what we call x, okay? So just bear with me for a second. So here we have 5 squared equals 25. That's exponential form. To put it into log form, this 5 is considered our base. It goes down, so we have log base 5. So imagine this log coming down, or this base coming down, and then the 2 and the 25 will switch. So log base 5 of 25 equals 2. So I want you to try switching the next one. We've got 10 to the negative 2 equals 1 over 100. The 10 comes down, the 2 and the 1 over 100 will switch.
Do we change the we don't change the negative, right?
Right. We don't change the negative. So it's log, what becomes the base? 10 of what? 1 over 100. Good. Equals negative 2. Good. So the 10 comes down, the negative 2, and the 1 over 100 will switch. Okay, what about the next one? We've got log base what? E of square root of E equals 1 over 2. Now, anytime you see log base E like this, instead of writing log base E, that is for babies, and we are not babies, we are adults, we're going to write ln, and that ln is called the natural log. Remember us talking about E last class? How it hit every single point. It was like the natural growth. That's what e is. And so when you have a log with a base of an e, it's called the natural log.
So you don't need to put log in, you just put
No, you just put ln. So on the next example, we have the log form, and it's ln of q equals n. So if I want to convert it back, this ln is like saying log base e, right? It's like saying that. So if I wanted to switch it back to exponential form, that e would come up, and the q and the n would switch. So what would the exponential form look like? E to the n power equals q. Good. Good. Feel good about this so far.
But what are we solving? We're just moving it around.
Right now we have all numbers in. We don't have any x's or anything yet. Eventually we'll get to the point where one of these will be an x and you're solving. Okay? We're just kind of using all numbers for right now. So the most common logarithm that you see, like if you were to just type in log into your calculator, it has a base of 10. So if the base is 10, it looks like log base 10 of, let's just say, m, like any number. You may just see it written like log of m. So if there's nothing there, it's implied that it's a 10. So if there's nothing there, it's an implied 10. If you see nothing there, just says log of m. That's an ugly green color. Poopy green. And then the natural log is with a base of e. So if I had log base e of x, it's more commonly or almost always written as ln of x. And I like making my L's like that when I draw ln. I don't know why. Just a little curly L. You don't have to. Just kind of fun. And sometimes it's better to do it that way because you might get confused and think it's a 1 when it's really an L. So all that a log is, generally, is that it's an exponent. So if I said 3 squared is 9, that's the exponential form. What's the log form?
Wait, give me a second. It's going to be log 3, 9 equals 2.
So if I replaced this with an x, and I'm giving you a super easy example right now. 3 to the x equals 9. And I wanted to move that to exponential form. Then I would say log base 3 of 9 equals x. And the way that I view it now in log form is I think when it's written like this, to solve for x, I think how do I get from 3 to 9? Like what power do I have to raise it to?
The second half.
2. And I gave you a really easy example, but it's going to get to where the examples are more difficult. But
So
we all know
always going to be like a number that actually works for it.
it'll always be a number that works, but it won't be.
Like, will it be a decimal sometimes?
You won't see decimals unless we use our calculator. But we'll just do some. Yeah, I'll give you some fractions too. Okay, so if you're solving a log, you're thinking, how do I get from base to the number? And you can even write that. How do I get from the base to, I just call that the number, but like here, 3 to 9. I have to raise it to the second power.
is the number like technically the A term?
Mhm.
What's
So here are some shortcuts.
Yeah.
Some examples that you're going to see that you can just look at it and know the answer automatically. The first one is when you have, so we know right now that x to the 0 equals 1. Like any number to the 0 power is equal to 1. If I change that to log form, that would be log base what? X of 1 equals 0. So what that's saying is if we call x, right here, if we call that any number or any base, it doesn't matter if there is a 1, a 2, a 3, an 857, anything, any number there. If I have a log of 1, that's always going to equal 0. So like log base 50 of 1 is 0. Log base, no base, like base of 10 of 1 equals 0. So the first rule, just put on my desk. The first rule is log or ln of 1 is always 0. So these answers are both 0. Erase that. So if you ever see a 1 in the slot, not the base slot, but the number, that's always going to be equal to 0. Because what it's essentially saying is it's raising it to the 0 power. The second one is look for the same base. So if you notice that the base and then the number next to it are the same, like that they match, that will always equal 1. So if I had log base 2 of 2, that equals 1. Because if you think about it, let's change that back to exponential form. So like let's just call this x for a second. I don't know what it is yet. If I change it back to exponential form, what does that look like?
log 2 of x equals 2?
2 to the
Or
what
not
power? X power equals 2. So that means that this is always 1.
Okay, so why is there an x to the 2? Why is it
Well, we're going to answer that in a second. Okay. So if I gave you another one, just going to erase this one. If I said log base 5 of 25, that would be like saying log base 5 of 5 squared, right?
Yes.
And these would then cancel to be 1. Now, when you have an exponent, like here, hold on. When you have an exponent, like here, we'll just look at A and B for a second. When you have an exponent next to a log, it jumps out in front before you solve it. So make yourself a note that if you have an exponent in a log, it jumps out front. So A is like really saying x times log base 2 of 2. And then B is really like saying x times ln of E.
So why wouldn't we change the log to 2 to 1?
We are. So then this becomes 1. So my answer is just x. This ln of e just becomes 1. Because ln of e is like saying log base e of e. That's really just 1. So my answer is just x.
I'm kind of confused.
Yeah.
So you have your exponent. It moves out front. If your base and then the number next to it are the same, that will then cancel and the whole thing becomes 1.
Why is the whole thing?
Because
Log doesn't mean anything.
no, it's like if I change this back to exponential form, it would be like saying 2 to the first power equals 2. Is that a true statement? So then that's why it's 1.
Okay, can you do the same thing with b?
With b, it would be like saying e to the first power equals e.
It's like when you do what? So log 2 to the second power. What's the answer to that?
That's 1.
Yes. So you can replace log 2 to the second power with 1.
Yeah.
Because the answer is 1 to log 2 to the second power, you can replace the whole thing to 1. You can substitute log 2 to the second
Well,
power.
don't
with
say
1.
don't get caught up in saying log 2 to the second power. It's like saying log base 2
log
of
base
2.
of 2.
Yeah.
Sorry.
So when we were talking about logs a second ago, when I said, so I've got log base 2 of 2. To solve this, I think, how do I get, like what power do I raise it to get from here to here?
1.
1. So the answer is 1. So this whole thing, oh, that was an eraser. So to get from here to here, I raise it to the first power. Okay, so that's why the answer is 1. Okay, we're going to keep going. Just need some practice, okay? So then let's look at C and D. This is now just an exponential form, but the same rule applies. So I have e to the ln. Those two are the same basis, because it's really like saying e to the log base e of x. These will cancel, or they become 1. E and log e become 1. This x jumps out in front. And the answer is just x. Same thing for D. The 5 and the log 5, same base. What happens to them? Cancel. The x jumps out in front, so the answer is just x.
So if the base and the, I don't know, big number, I forgot
Mhm.
which point, are the same,
They
then-
cancel to become 1, yes.
What is the big number called again?
Yeah, I don't know what that's called.
We just use
Isn't it
8.38.
2.7?
This one is just, like, this one would be like the big base, and then this would be log of a base.
I'm just gonna call it the big number today.
That's fine. That's fine. Okay. So let's do some examples together. And it's going to take some practice. But like I said, we just got to keep working at it. Okay? And this is all we have left for today. So we're going to go through it pretty slow.
This page right here?
Yes. This is all that's left. And then you'll have some time to do some homework. So ln of e. I've already explained that, Graham. ln of e. It's like saying log base e to e. E of e. So what would that equal? 1. ln of e squared. What happens to this exponent? Jumps out front. So the answer is just 2.
Okay. So when you have it to any exponent, you're multiplying at the end.
Mm-hmm. Number 3, and if you want to write log of e instead over it, you can, if that helps you. In my head, I just think log of e. So how do I get from e to 1 over e? What power do I raise it to?
-1.
-1, good.
Wait.
So in my head, like, here's the process of what I'm going through. I've got log base e of 1 over e. I'm just writing it the other way instead of ln. I think the process is, how do I get from here to here? What exponent do I raise it to? And that's how we got the -1. Because e to the -1 equals 1 over e. Okay? Number 4, e to the ln of 4. What do we think about that?
So is that,
Is that where you take the 4 and take it out? Like,
Yep.
so is e and then
E and
to the
ln will cancel out. You're just left with 4.
even if the ln is like where you ln.
Like, I
Mhm.
get that they cancel out, but I don't really get how, like,
They're
I'm
the same
supposed to
thing.
cancel out. Like, I get, like, e and log e cancel out, but
Mhm. Because it would be like e to the ln is just like how do I get from e to log e? It's like raising that to the power. So e to the first power is e. That's why the answer is 1. Okay, what about number 5? 3?
because the 4's cancel.
Yeah, so this 3 jumps out.
And then 3 again.
Okay, what about 6?
3 again.
3 again, good. Because to get from 2 to 8, you raise it to the third power. Okay, this one. How do I get from 5 to 1 over the square root of 5?
-1/2.
-1/2. Y'all are amazing.
Tell me
Y'all are
more.
so good at this.
I get the negative part, but why is it half?
Because square root of 5.
If it was just
You get the negative because it brings it down, but then the square root of 5, like to get from 5 to square root of 5, you have to do the 1/2 power.
Okay.
Okay.
if it was just
And then the
-1/2,
negative brings it 1 over.
1/5.
Okay. So log 9. So
10 to log of 9, but if there's no base under the log, it's understood that it's what? 10. So you can just add a little 10 there if you want. So the answer is
How am I supposed to just
9.
Because wait,
Yeah,
it's for number
understood.
4.
It's understood. It's implied.
Oh,
For number 4, it's basically the
invisible.
same thing.
I'm trying so
It's
hard.
imaginary.
ln.
Okay.
It's log e.
Here's what I want you to do. I want you to try 9 through 17 on your own. I'm going to let you spread your wings and fly. Okay?
Or
Just
yeah,
fly. And then, no, I
Fall.
believe in you. So
gonna fall out of
you're
this
going to get
list.
answers that are fractions, and they could be negative fractions, but they're all going to work out nicely. You're not going to get decimals.
Are there imaginary
They'll be
fractions?
fractions.
Okay, what about 17? Can
So,
you show us how to do
so
that?
like for the number 9,
That's
like,
just like time.
could you not just say like, so it has to be like a power, it's not like
It's a power. It's
so
not
like 7
multiplied.
times 7.
Right, right.
Wait.
I will do one of them with you that turns out to be a fraction.
Okay, can you do 13?
11.
Alright, 11.
11, no. It's just
13,
going
13,
backwards.
13.
11 is just going backwards, so it's
11
taking the
is-
square
11
root.
is just 1/2, isn't it?
or 1/2?
It's just
1/2.
It's just one
Okay.
half.
Ooh, boom. Is that the whole answer? Is 1/2?
Yeah.
So what's this?
So this one's 1/2.
Okay, and so then
Let's
30
do, I'm going to say number 14, okay?
Okay, great.
Let's do number 14. So to go from,
It's 1/3.
no, it's not 1/3 because that would be 3.
Oh, so it's 3 over 2.
It's 2/3.
2/3. That's
2/3.
what I meant to say.
But let's think about how I get this, okay?
Let me tell you about it.
So if I were to put this back into exponential form, you would have like 27
Whoa.
to some power, let's call it x, and you can put equals x on the end of all of these if it helps you. So if you want to put equals x on the end of all of these, you can.
Okay, wait. Can you explain number 10?
Nope, not yet.
Nope. Oh.
Hold on. So 27 to some power equals 9. So if I want to figure out how to get, because I understand that I need to cube root it to get to 3. Like, so let's bring them both to a base of 3 really quickly. 27 is like saying what? 3
3 to
3 cubed. And 9 is like saying
3 squared.
3 squared.
So you put the
But I still need to keep this x here. Once they have this same base, like they both are set to 3, you can just set these equal to each other. So 3x equals 2.
Wait.
So once you have them both set to the same base, 3x equals 2, so x equals 2/3.
So wait, what do you mean by they're equal to the same base? When they both have
Like they both have the same, like they're both base of 3.
God.
Wait, I need you to show me that.
That helps so much.
I need a read.
Can you do that for like everything?
So you could, yeah. You could do it for all of them. I
That
sometimes,
doesn't make
so
sense, but
some
I
of
did it in my
them,
head and it was a lot easier.
you can, if you can do it in your head, that's fine too.
Yeah, 'cause I just
So
felt like
some of them you can look at and automatically in your head it's going to be squared or it's going to be 1/2. The ones where you get a fraction that's like 2/3 or 3/2, that's where it gets a little bit more tricky. So like number 16, for instance, if I say that this equals x, yes,
It is?
yeah.
Okay,
Y'all
wait.
are just coming up with these in your head.
I just did the
Actually,
little
I'm
help
pretty
thing,
much.
and that's oh my god.
So
Okay,
like
wait, go through
number
16,
number
'cause I didn't
16, it would be like 8 to the x power equals 32.
Oh, and then you
Make
then
them
you
both
figure
base
it
of
makes
2.
it 2 to the 5th power is 32. Got it.
2 to 3x equals 2 to the 5th.
Yeah, I don't
And
get
then-
that part, but I get
And then these
in
both,
my head.
3x equals 5, so x equals 5/3.
Is the answer number 12 -2?
Negative 1/2. So
We just go smaller,
a good rule like to
Like the
think
same
about,
thing.
I'm going to erase this. If you're going from, so like if your base is small and the number next to it is big, so if you're going from small to big, then you're going to have a number greater than 1. Like you're going to have like 2 or 3 or 4, like it's something bigger than 1. But if you're going from big to small, so for instance on number 11, you're going from 49 to 7. So you're going down, you're going smaller. You're going to have a fraction for an answer.
Gotcha. Okay, wait.
And then if you have like a 1/something, then your answer is going to be negative.
Is number 10 -2?
Don't. So I'm going to give you 7 minutes, and I want you to try and fill out all of them, and then we're going to go through them, okay? So if we look at number 12, that's where I started the blue part, because that's when I started to think I can't just in my head do it, okay? So you take these two, and you put them both on each side. So like 49 equals 1/7. And we think about what base do they have in common. They both have 7 as a base in common. So this is like saying 7 squared, and this is like saying 7 to the -1. And put an x right there. And then set the exponents equal to each other. So 2x equals -1. And x, so then divide by 2, x equals -1/2.
Okay.
I wish I would have made that earlier.
So that's how I'm getting all the other blue parts.
Yeah, because like I can do them in my head, but I gotta learn the blue part better.
So like on 15, I'm saying 27 to the x power equals 81. Then I change them both to be 3. So 3 cubed,
'Cause that's
3
like
to
a
the
common
4th.
root that they
Mhm.
have. Is that what you mean by base? Is
Yeah.
Root?
like a common
Okay.
root.
And so then that would then both equal 3, and then you put the exponent that would make it to what it is.
And then on number 17, I changed this 0.01, this decimal, to be 1/100, because that's the same thing. Like 0.01 and 1/100 is the same thing. So if I've got 1/100 to the x power equals 1,000. 1/100 is like saying 10 to the -2. And 1,000 is like saying 10 to the 3rd power. So -2x equals 3. And so x equals -3/2.